Hi, welcome back to our last example 3 for 4.1 special angles. In this example, we're just going to do an application of the trig ratios. So it says an air traffic controller observes that a value air flight is 20 kilometers due east, that means towards the east direction, of the control tower, while a first class air flight is 25 kilometers in a direction 10 degrees west of north from the control tower. What is the angle of separation of the two aircraft as seen from the tower? Okay, so this is going to require us to draw a diagram. So if this is the air traffic controller, so I'll write it as ATC, air traffic controller. It says value air is 20 kilometers due east. So we're just using a regular compass for this, north, south, east, and west. Okay, so if it's 20 kilometers due east, value air, it's going to be somewhere out here. So I'm going to write VA for value air. And there's a distance of 20 kilometers. Okay, then it says first class air flight is 25 kilometers in a direction of 10 degrees west of north from the control tower. So north is straight, I guess you could say forwards for the air traffic controller. This points north. Okay, and it says first class is in a direction 10 degrees west of north. So if this is north, it's an extra 10 degrees west of north. So I'd have to rotate another 10 degrees. So it's going to be along there. Its distance is 25, so it's going to be a little bit farther away. We'll call this FC for first class. Okay, and in here there's an angle of 10 degrees because it says it's 10 degrees west of north. So I start at north and I just rotate 10 towards the west direction. Okay, because west is this way. So what's the total angle of separation of the two aircraft? Well, it's going to have to be that 90 degrees plus the 10. So we can say angle of separation is equal to 90 plus 10. It's going to be equal to 100 degrees. Okay, maybe you could have figured that out without having to draw the picture, but I do recommend you do that way you don't make any mistakes along the way. So it says construct a unit circle to determine the cosine of the angle in part A. So now they want to know what is cos of this angle. So they want us to use the unit circle in order to do that. No problem at all. So what I'm going to do to kind of make my life a little easier, you guys probably already know what I'm going to say. I'm going to copy paste this over what I drew. And I'm just going to center it. I'm going to center the air traffic controller at the origin. Okay. I'm just going to erase that piece there. Okay, there you go. So part B wants to know what is cosine of this angle. So is these a unit circle? So that means I need to draw a circle through here. So I'm going to make this go up a little bit higher. I'm going to draw my unit circle through here. So that's -1 here. We got +1 up there. And maybe we're somewhere out over here like this. Okay, they're not a very great circle. But anyway, the most important part is that we have this point on the unit circle. So what is this angle in here? Well, remember the ordered pair. The x value is cos of the angle. The y value is sine of the angle. So it says, what is cosine of the angle? Well, it's going to be this x value right along here. Okay. So I think it looks like it's probably around like 0.2 because there's halfway and it looks like it's kind of right in between that, maybe a little bit less. So I'm going to go with 0.2. So this is just an approximate answer, not the actual value. So I'm just going to say, therefore, cosine of 100 is approximately 0.2. Okay, and if I would have drawn a really good unit circle, we probably would be a little bit more accurate, especially if we had it on grid paper. I do want to do a quick check just to see how accurate my drawing was. I'm going to type in cos of 100. Okay, and I got 0.8. Okay, I'm back in radians, switch over to degrees, and there we go. Negative 0.17. So yeah, actually I did make a little bit of a mistake here. This is negative side, right? Maybe you might have picked up on that. So we should write negative 0.2. Move that over. I'm going to add a little negative sign in here. Okay, so Desmos, I got negative 0.17. So it actually was pretty close using my diagram. Make sure you pay attention to the sign. Okay, so your coordinates, make sure you include the negative values. So if I had to write out this coordinate up here, I would say negative 0.2. And the y value, I would say it's so close to 1, I'd probably say like 0.95, something like that. Okay. So that means sine of 100 would be 0.95. I always want to check that real quick, just for curiosity's sake. 0.98. So still like pretty close with these drawings. So not as good as the calculator. What we're going to be doing in further lessons is we're going to be using some special triangles mixed in with the unit circle. That way we're going to get really accurate trig ratios. Anyway, that is it for 4.1. I'll see you guys in the next lesson.